So part 2, hopefully you took a few seconds to actually try this problem. And we'll find out if we needed to use any of the inverses, meaning the arcsine or arctangent or arccosine. Well, let's fill it in. What do we got here? Zx. There it is. It's 24. And yz is 27. Now, it would be very silly to ask you for angle z at this point because it's obviously 90. So we asked for angle x. So I could have asked for y, but this time I asked for x. And so now we have to realize that my calculator can figure out sine, cosine, or tangent of any angle, but I don't know the angle. It's just sitting there. Nothing's there. So then we have to figure out, well, we know opposite, and we know that this one over there is hypotenuse, which means this one has to be adjacent. And so then we got to figure out, well, which one am I going to ask my calculator to basically do then? Well, we have to figure out which one we know. Well, if we know opposite over adjacent, remember this only works for a right triangle. Opposite over adjacent leads us to tangent. So tangent of some angle I don't know, we'll call it x because that's what it is over there, equals 27 over 24. And remember, tangent is the one of the three that can actually be bigger than 1. And so this is the case where we have to decide, am I going to try and divide by the tangent of something? Well, no, because I want to get tangent away from the angle, and there's only one way to do that, and that's with arctangent, or tangent to the -1. But if you do that to one side of the equation, you have to do it to the other. And on this side, they just cancel, leaving you with x equals whatever. Again, remember, it can be written this way. Arctan of 27 over 24 happens to be. Now let's go find out. And seeing this was recorded at a different time, I better make sure I'm in degrees. Yep. Because that's how I would like the answer given to me. I don't want it in radians, at least not in geometry class. So arctan's right there, tan to the -1, and we do 27 divided by 24. That's how you do the over here. And hopefully that will give me an answer. 48, well, that makes sense. So x is approximately 48 point, does it say we're around nearest tenth? So 48.4 degrees. It'll become very important once you go on that you put the degree symbol there, but for now I think we understand that it's degrees. And obviously at this point you could go get angle y if you had to. You could just use the total as 180 if you wanted to. Had I asked you for the hypotenuse here, you could have just done Pythagorean theorem. You wouldn't need to do SOHCAHTOA. Right, hopefully you got that down. All right. A surveyor, hopefully you know, well, there's lots of different types of surveyors, but this would be a land surveyor. Those are the people that are out by the side of the road every once in a while with the tripod and telescope looking thing. Is 130 feet from an obelisk. Remember, an obelisk from earlier this year is like the Washington Monument. The tower, or the obelisk, whatever you want to call it, is 86 feet high. The surveyor's theodolite, that's what it's called, or it's sometimes called a transit, or the little telescope looking thing, is 4.7 feet above the ground. Determine the angle of elevation. I think I have a picture. Yep, there's the guy. There he is. That thing right there is the theodolite. That's the surveyor. There's your obelisk. All right. So we have to be very careful when we draw this picture. We know that the surveyor is 130 feet from it. All right. 130 feet. We know that the tower or obelisk, whatever you want to call it, is 86 feet high. And we know that this thing right here is 4.75 feet above the ground. So this is not drawn to scale. Determine the angle of elevation. It's very important. It's very easy to do that wrong. Remember, angle of elevation is the difference between looking straight ahead and looking up. That's what angle of elevation is. So that is what we are trying to determine here. Now you have to be very, very careful what you put for this side right over here of your triangle. If you put 86 for that side of your triangle, you are going to get it wrong, because that is not that tall. But luckily we know that this distance right there is 4.75. So basically we have to cut off the 4.75 from the 86. And I saw some calculators at work there, which is a little bit sad, but 81.25 feet, of course. Well, it still seems as though we're missing. So here, we'll call this x. That's what I want to find. It seems like we're still missing information, though. Because to use SOHCAHTOA, you at least need 2 bits of information. And luckily, we know that this one right there is 130 feet. Okay. So we will say there's our right angle. So this one over here is hypotenuse. Perhaps we should use a different color. Well, that's hypotenuse, which means this one over here is opposite, making this one adjacent. And really, when you do a lot of these, tangent does happen a lot. And again, we have opposite and adjacent, which in SOHCAHTOA, remember it's very important to spell it right, is tangent. So tangent of some angle that we don't know, we'll call it x, equals opposite, which is 81.25, over adjacent, which is 130. So this time tangent actually isn't bigger than 1, but it is the one that actually has that possibility. So to solve this, once again, we do actually have to get tangent away from the angle, so arctangent of both sides, canceling here, because they are inverses. So then that's what we'll have to type into our calculator, the arctangent of 81.25 over 130. All right, let's get rid of that one. We don't need that anymore. Arctangent of 81.25 divided by 130. Pretty much 32 degrees. Any questions? All right.